Siberia. This remote and sparsely populated part of Russia lies within the Republic of Sakha, and the region here is called Yakutia. There is an ancient Siberian legend which says that God was once flying over Yakutia with a bag of earth treasures. But because of the extreme cold, his hands became frozen, and he spilled all of the wealth across this region. Yakutia is indeed one of the richest regions in the world in terms of natural resources. This region is also very rich in permafrost. The permafrost here is continuous, can be up to 500 meters deep, and has very high amounts of ground ice. And permafrost stores a lot of carbon, more than twice as what currently exists in the atmosphere. When permafrost thaws, this carbon is released and can worsen climate change, as the carbon is transformed to carbon dioxide and methane by different microorganisms. Permafrost is very sensitive to changes in temperature and precipitation, and the Arctic is currently warming even faster than the rest of the world. Climate change, along with other human activities, like cutting down forests for agricultural land, is causing permafrost degradation. This degradation in areas of ice-rich permafrost often causes a process called thermokarst, which eventually results in the formation of numerous lakes in regions where topography is flat. Once a lake begins to form, the high heat capacity of the water can quickly thaw the surrounding permafrost, releasing the stored carbon. Thermokarst lakes are very common in Yakutia and can be hotspots for greenhouse gas emissions. We wanted to know if there are differences in the amount of dissolved carbon dioxide and methane between three common types of thermokarst lake in Yakutia: unconnected Alice lakes, connected Alice lakes, and recent thermokarst lakes. We also wanted to know if the concentrations of dissolved greenhouse gases varied between the seasons. We collected dissolved greenhouse gas samples from 33 lakes near the village of Siedach in Yakutia during all 4 seasons. Our results show that all 3 lake types were very oversaturated in carbon dioxide compared to the atmosphere during the winter, up to 2 orders of magnitude greater than other seasons, although recent thermokarst lakes were the strongest source of carbon dioxide. Summer also showed oversaturation in carbon dioxide for most lakes. In the spring, however, most lakes acted as carbon dioxide sinks, actually drawing CO2 from the atmosphere. All 3 lake types acted as sources of methane during all 4 seasons, although unconnected Alice lakes were the strongest source, especially during the fall. These differences in greenhouse gas saturations between lake types and between seasons are likely due to differences in lake morphology and seasonal lake conditions. For example, unconnected Alice lakes, which are no longer expanding into surrounding permafrost, are usually shallow and very nutrient-rich, which causes them to be hotspots for plant growth in the ice-free seasons. This plant growth requires a lot of carbon dioxide, which in turn creates a very favorable environment for methanogenesis. Recent thermokarst lakes are still expanding into the surrounding permafrost, which is likely generating a high input of fresh carbon into these lakes. This input, combined with these lakes being stratified in the summer and winter, leads to very high amounts of dissolved methane in thermokarst lakes. We also determined that the diffusive fluxes of both carbon dioxide and methane from these lakes, which we calculated using the dissolved greenhouse gas concentrations and wind data, are among the highest presented across the Arctic and subarctic regions. The high levels of temporal and spatial heterogeneity between seasons and lake types illustrates the complexities of these permafrost landscapes and their responses to climate change and other anthropogenic influences. There's more work to do, and we look forward to continuing to collaborate with the Melnikov Permafrost Institute and continuing our work in Siberia. Thank you for listening, and check out our paper in Limnology and Oceanography.